Welcome. Today we will start finding support reaction for cantilever beam subjected to UVL represented by a trapezium. Actually yesterday by mistake in the title I wrote trapezium, but it was recording was done, but in the yesterday's class, which I uploaded, but it was a triangular UVL represented by triangle closing part. So I changed it already now. Today it is trapezium. Okay. Question 23 dictated. See, read the question properly. A cantilever beam is of length L. It is loaded by an uniformly varying load of intensity W1 at the fixed end, which linearly reduces to W2 at the free end. I never tell left and right end. See, uniformly varying load with the intensity W1 per unit length at the fixed end, which linearly reduces to W2 per unit length at the free end. W1 here, W2 here. Okay, this is a given beam. Usual statement. Make a note. You can take either left side fixed or right side fixed. I will first solve for left side fixed. Right side fixed, briefly I will tell solution here. Very briefly I will give you. Start. As usual, VA, MA, take moment about this point. Before that, I should not tell. It is told so many times. See, trapezium. You can calculate the total load and moment of the load in a single step. See, centroid will be somewhere here. Make a note. Light line, little this side. Somewhere here, centroid. I should not tell actually. Now, you write light line. This distance, you write x bar. Now see, start. Sigma m about a equal to 0, clockwise positive, plus total load. Total load is area of the trapezium. Sum of the two parallel sides, W1 plus W2, divided by 2 into distance between the parallel sides, L. This is told many times earlier. Okay, this is total load into the total load is acting as, see, this is a total load into this distance. From here to centroid is this side plus twice of that side divided by this side plus that side into distance between the two parallel sides divided by 3. So the total load is here into this distance is W1 plus twice of W2 divided by W1 plus W2 into L divided by 3 equal to 0. So MA will come, see, W1 plus W2, W1 plus W2 will cancel. See, a light line, you can make a note. See, this will cancel. Therefore, what remains? W1 plus 2W2 into L is L square by 6 is the answer. Now, sigma V0 upward positive plus VA minus total load W1 plus W2 divided by 2 into L equal to 0, you get the value of VA. Neatly enter the answer. See here, right here. Neatly enter the answer little later, not now. We'll enter the answer little later because I want, for some reason, I want to enter the answer, but little later. Or, make a note here. Those people who find difficulty for trapezium, what you do is right here, or see this trapezium you divide into a rectangle and a triangle. First of all, I should not explain all these things again and again because it is told many times, not once. Still, one rough sketch I will give here. This I will remove now. See. Or, see here. This trapezium. Actually, what you have to do, once you write this one, or right here, see, this way, W1, this is per unit length, W2, per unit length, okay, equal to a rectangle of W2, this is the rectangle, this will be W2 only, and a triangle, it will come this way. This will be W1 minus W2. Because W1 is taken more. W1 minus W2. Now, this is UDL acting to center. This is somewhere here. Okay, start. Sigma m about A0 plus W2 into L is the total load, UDL. W2 per unit length into L into L by 2 clockwise plus half into L into W1 minus W2 is the total load into 1/3 of L, because by chance if it goes this way, in some other question you have to make 2/3. 1/3 of L equals 0 minus MA equal to 0. Simplify, MA will come, see, W2 L square by 2 plus W1 L square by 6 minus W2 L square by 6, or W1 L square by C, W2 L square, W1 L square by 6 plus W2 L square into 1 by 2 minus 1 by 6 is 1 by 3, or you can take 6 common denominator, it is L square by 6 times W1 plus 2W2 over. Now, one small hint, where you got to, that is the reacting moment equal to this intensity plus twice of free end intensity. If you want to write a words, fixed end moment is this intensity plus twice of the free end intensity into L square by 6. I will ask a question, why twice came to other side? See, as the intensity free end increases, what will happen? Moment will become more and more. That's why predominant is free end intensity. See, free end intensity, if it increases, it will create high moment. That's why 2 times came here. Okay, this question is completed. Now lastly, present the answer. No, instead of wasting time, you can do one thing here. Okay, I write here. Therefore, final support reactions will be as shown here below. Okay, put a sketch. Final answer. Okay, 1 minute. I want, for some reason, this I'll remove. No, I want that answer to be written separately. Some important point I want to tell at the end of this class. Okay. Therefore, right here. Therefore, for question number 23, see, for question number 23, the final, right here, the final reactions will, or support reactions will be as shown below. This way, see, intensity here is W1 per unit length, which linearly reduces to W2 per unit length here, length of cantilever is L. If I take this is A, B, this is the uniformly varying load, this reacting moment MA, this MA equal to, see here, L square by 6, L square by 6, or you can put, if you want, suppose you want W1, some people want WL square format, you can change it, or equal to the reacting moment MA equal to W1 plus 2W2, I write here, MA, W1 plus 2W2, again no space problem here, see, whatever I do, space problem comes. Okay, I'll manage. Don't worry about these things, small things. It became a little dirty there. Okay, see, I'll put arrow mark closer. This is A, this reacting moment, I write here, reacting moment MA equal to W1 plus 2W2 into L square by 6, and this reaction VA equal to, where is the VA? Okay, why it is W1 plus W2 divided by 2 into L. Right? I already know the answer. Total load W1 plus W2 divided by 2 into L is the reaction. This is the final answer. I will keep it. Question number 23. Remember, it is the final answer. Okay. For some reason, I want this answer as it is. I do not want to remove it. For some reason some interesting point I will tell you. Okay, now go to question number 24. 24. Question will be dictated for you. I will again do that time, I will do a numerical question. See, what I will do is, see, I will write the question here. A cantilever beam is of length, started raining there, any length, some small length, is of length 2.5 meter. It is loaded by uniformly varying load of intensity 10 kN per meter at fixed end, which 20 kN per meter at fixed end, which linearly increases to, see now, last time W1 at the fixed end, I told linearly decreases. Now it linearly increases to 50 kilonewton per meter at the free end. Okay. This is a question given. A and B. Find support reaction. Usual problem. Started raining. Sounds are disturbing. Pause for some time. I do not want any sound disturbance. I'll start now. It rained for around half an hour. So I wrote everything now to save time. Okay, see, I told cantilever beam of length 2.5 meter. I am not told where fixed end. It is your choice. It is loaded by uniformly varying load with intensity of 20 kN per meter at the fixed end, which linearly increases. See, last time linearly decreases I given. Now linearly increases to 50 kN per meter at the free end. Find support reactions. Let VAMA as usual. Okay, start. See, first direct total load is acting here. If you want, remember this is X bar. I should not explain now. Total load equal to 20 plus 50 divided by 2 into 2.5. That is area of the trapezium. See, you can see here. Distance is 20 plus twice of 50 divided by 20 plus 50 into 2.5 divided by 3 minus MA 0. MA will come 125. Sigma V0, I don't have to explain. VA will come plus 87.5. Therefore, write the answer. See question 24. 20 to 50 kN per meter means 87.5 and 125. Answer. Now, or people who find trapezium difficult. See, for this one, you do one thing. Make a note here. Suppose you do not want trapezium, then see, now you write it. One rectangle of 20. Then 20 already over here, 20. So this is 50. So extra is 30. If you cannot get this much, no point in studying structural engineering. Okay, now start. See, two loads are there. Now, when you take moment about A, 20 kN per meter for 2.5 meter UDL into 2.5 by 2. Load, see, load into distance, and half into 2.5 into 30 is the load into, now it is 2/3. See, last time it was 1/3. Now it is 2/3 of 2.5. MA will come 125. Sigma V0, you write it here. Plus VA minus 20 into 2.5 minus half into 2.5 into 30 equal to 0. VA will come 87.5. Enter the reaction. Okay. Now, some interesting discussion will be there little later. Now I will come to question number 25. 25, what I will do is, I will take fixed and right side. See, first of all, in the question, nothing given. Okay. I write the question first. Okay, VA, VB, I will remove that also. You write now. Let VA, let VB, you write. Okay, start. I already wrote the question there. Now there is a question, bookwork type, but with, see, last one question, W1, W2, both are not interconnected. Now, it is in terms of W. So, it is actually little simple compared to question 23, little easier. See, a cantilever beam, see, is of length L. It is my choice. I can take either left side fixed or right side fixed. So this time I will take, just for a change, right side fixed. I will tell afterwards, right side fixed. Okay, my choice, AB. Then it is loaded by uniformly varying load of intensity 2W per unit length at the fixed end. 2W per unit length at the fixed end, which linearly increases to 5W per unit length at the free end. So fixed end is here, 2W per unit length. Where you took fixed end there, here increases linearly to 5W per unit length. This is the trapezium. Okay. Span is L. Write the sketch here. Now, to save the time, you first copy the question. Do not write anything in the question. Now write solution. When you write solution, write here. See, fixed end at B. Let V be upward and MB, now MB will be clockwise. Clockwise, B vertical reaction and reacting moment at the fixed end B. So enter here. Actually, one more sketch you have to write. Don't enter here. MB, this is to save the time. See, I can do whatever I want. I can enter the same sketch, but you should not do it. If you practice that way, later doubt will come. See, who will tell you this direction? Once you put the statement, then write here. So start. Sigma I am about B0. Some will ask, why B? Sorry, I am not explaining why B. If you still do not know why B means, you are wasting your time attending my classes. Okay. Take note about B. See, total load here. Let this side. 5W plus 2W plus 2W divided by 2 into L, that is area of the trapezium, is the total load. It's a total load. Multiplied by, from fixed end, moment about B you are taking, into this distance you want. That distance is 2W plus twice of 5W divided by single stretch, divided by 2W plus 5W into distance between them is L divided by 3, then minus MA equal to 0. Now see, this 5W plus 2W, this cancels. What do you get? 2W plus twice of 5W. 5 into 2 is 10. 5 into 2 is 10. 10 plus 2 is the 2W2. No, it is not 5W. If it is 5W, it will not match with that one. Yes, correct. 2W, 5W. Okay. 5 into 2 is 10. 10 plus 2 is 12. 12, see, you will get, see here, 5 into 2 is 10. 10 plus 2 is 12. It is 12 L by 3 into L by 2. 3, 4 times. Anything missing here? 1 minute. 2 into 3 is 6. Yes. I think everything is correct. Okay, it will be, MA will come. How much? W L square divided by, no, it is still, cut. See here, 5 to 10 into 12 into L by 3 into L by 2, 3 to 6, 2WL square. Ayyo, why I am worrying? Plus also important. See, I know the answer there. See, I already calculated earlier. I did not see it. Okay, plus 2WL square. I see, for getting that answer, I did not write anything. I used only calculator. I will tell you how I calculate if you want. Okay. Then sigma V equal to 0. Take upward positive. Plus VA. Not VA. It's not MA. It is MB. Oh, see, too much of extent. Okay, MB plus VB minus the total load. 5W plus 2W divided by 2 into L equal to 0. Your VB will come 5 plus 2, 7. 7 by 2 WL. 7 by 2 WL. This is the answer. Okay, now make a note. People who find difficulty for trapezium. One round explanation will be there now. After everything is over, full board I will explain. See. Or make a note here. Those people who find difficulty for trapezium, what you do? You consider this way, cantilever little down. Cantilever beam like this. Fixed end here. See, one rectangle of 2W. Again started raining there. Droplets are coming. 2W. Here it is 5W, 2W means extra 3W. This is 2W per unit length. You write fully. This is 3W per unit length. Don't write per U, per unit length. Span is L. A and B. MB, VB. Okay. Take moment about B. Clockwise positive. Minus, see, one load here. One more load here. This load, 2W into L. See, this rectangle, UDL. It is actually anti-clockwise, so minus 2W into L is the load into center into L by 2. Again minus this uniformly varying load, half into L into 3W into, from here to here is 2 by 3 of L minus plus MB equal to 0. Your MB will come 2 into, this is 1, half into 3 into 2 by 3 is, calculate is not on, half into 3 into 2 by 3 is 1, 1 plus 1 is 2, okay. 2WL square plus 2WL square, 2WL square, see answer here, plus 2WL square. Sigma V0 you only write, plus VB minus 2W into L, this load, minus half into L into 3W is that load, you get 7 by 2 WL. All the answers are over now. Okay, now I will tell you how I got in calculator. See, if you got confidence, you can do it. I won't write anything. See, I will write here. I will start from here only. First, people locate CG first. No, directly from in the correct order. 2 plus 5 divided by 2 into 1 is the total load into bracket 2 plus twice of 5 divided by 2 plus 5 into 1 by 3. Correctly 2. 2W L square came. See? So, little confidence required. Directly I told, see, what I had done? 2 plus 5 divided by 2 into L. 2 plus 5 divided by 2 into L is 1. It came 4.5. No. 2 plus 5 divided by 2 is 3.5 it came. Okay, then this distance is 2 plus twice of 5 divided by 2 plus 5 into 1 divided by 3 is some 0.571 came into 3.5. It came exactly 2. Okay, now this answer over. Now some interesting discussions are there. Unfortunately, same problem. Above the classroom here, sheets are there. So when it rains, some sound disturbance will come. So I have to wait till sound is completely over. But I will write all the sketches now. Okay, I can explain right now only. No, I do not want sounds. See, I wrote result for all the 3 questions, 23, 24, 25. I will just, this is only for information. See, this question it is given. In none of these questions, I told left side fixed or right side fixed. Simply told cantilever. When they simply tell cantilever, it is the duty of the person who give the question to give the reference point as either fixed end or free end. Nobody should tell a cantilever beam is of length say 5 meter loaded by a point load of 60 kilonewton at 2 meters from left end become nonsense. This I will explain once again later. If they tell a cantilever of length 5 meter is fixed at left end, okay, then they can tell. Clear. But if it is not mentioned fixed where, when they give location of the loads, they should refer either fixed end or free end. They should not tell left end, right end. Because some people may turn other way. See, instead of taking cantilever this way, if he takes this way, it is wrong solution. See, I tell example here. Just for example, suppose a cantilever beam, they give a question of length 5 meter. Okay, 5 meter. Loaded by a point load of 80 kilonewton at 2 meters from left end they give. Okay, now what somebody can do? Somebody can take a question like this. See, he will also put 5 meter here. He will put 80 kilonewton at 2 meters from here. This will become 3 meter. See here. When you take moment here, 80 into 2. Here, 80 into 3. Therefore, it is wrong to give left end reference point as left end and right end if it is not properly given which is fixed end. So, but that's why in all these 3 questions, I simply told, this question I told cantilever of length L. This question I told cantilever of length 2.5 meter. Again I told length L. See, what I told loading? I told loading maximum intensity of W1 per unit length at the left end linearly reduces to W2 per unit length at the right end. Okay, this is question 23. Suppose you want to practice other way. See, then while solving, I took left side fixed. See now, question 23, make a note. Suppose you take right side fixed, what do you have to do? Then see, length L, moment will come here, reaction here. In the question told, maximum of W1 per unit length at the fixed end. So you take W1 here, W2 here. That question. Then, now enjoy the question, correctly find. Suppose you divide into parts, then see, dividing is like this. This is W2, this is W1 minus W2. See here, see, right side W1 minus W2, triangle has got 0 left end, maximum right end. Here, 0 right end, maximum left end. That careful. Now solve the question. Your answer for VB and MB will exactly come equal to VA and MA. But here MA is anti-clockwise. Here MB will come clockwise. That's okay. But value will come same. Okay, then question 24. It is told cantilever of length 2.5 meter loaded by UVL of intensity 20 kN per meter at left fixed end and linearly increases to 50 kN per meter at right end or sorry at free end. See, again I made the mistake now. Or they can tell UVL of intensity 50 kN per meter at the free end linearly reduces to 20 kN per meter at the fixed end. Okay, this already is solved here. Therefore, do one thing, 125. Okay, see, if you solve here, if you take this way cantilever, solve it. Where fixed end is there, 20, see 20. Free end, 50. This way solve. If you split into parts, 30 and 20 will come. Now enjoy the question. Question 25. It is told a cantilever beam of length L. It is not given where fixed end. Loaded by, I don't remember what I told. Either I told intensity 2W per unit length at the fixed end linearly increases to 5W per unit length at the free end, or you can tell 5W per unit length at the free end linearly decreases to 2W per unit length at the fixed end. So this question, suppose you take other way, fixed here, then at the fixed end 2W, you take 2W here per unit length, here 5W. Dividing will come this way. Now solve all these questions. Now one important observation you can make if you are interested. See, these observations are important that will make your grip more and more. This is a general case. See, W1, W2, L. General case. See, here W1 is more, W2 is lesser. But you don't have to bother. Whatever intensity given here, it will come W1, free end will come 2W2. Even if it is increasing also, 2W2 will come. So, this is standard. See, here W1 is more, W2 lesser, does not matter for answer. But when you solve, it matters. Actually, for trapezium, it does not matter. But if you divide into rectangle and triangle, then it matters. Okay. Now, do one thing. You keep this as standard. See, he got here vertical reaction at a fixed end. We got W1 plus W2 divided by 2 into L, and reacting moment at fixed end, direction not required, fixed end, we got, what is the answer there? W1 plus 2W2 into L square by 6, very important. W1 is at fixed end, intensity. W2 is intensity at free end. That is very important. Okay, now see this question. Now see question number 25. You do one thing. Fixed end, see here. Don't see interchange here. At fixed end W1. W1 is 2W. In this equation, whatever you got here, substitute W1 equal to 2W, W2 equal to 5W, L equal to L only, you will get, see there, 2W plus 5W, that is this reaction will come 2W plus 5W divided by 2 into L. 5 plus 2 is 7. 7 by 2 WL. See the answer here. 7 by 2 WL. And the reacting moment will come, see here, W1, intensity at the fixed end, 2W plus twice of intensity at free end, 5W into L square by 6, or 5 into 2 is 10. 10 plus 2 is 12. 12 L square, 12 WL square, 12 WL square by 6. 2 times. Answer is 2 WL square. See answer here. 2 WL square. And lastly, use this question. Sorry, not that question. Use question number 25. Okay. Use this standard equation. This is use 23 only. Use 23. General case 23. See here. Fixed end is 20. So W1 is 20. W1 is 20. At fixed end, it is 20. Actually, don't see the sketch here, which big or small not required. Interchange here. What do you require? At the fixed end W1, free end 50. W2 equal to 50. So the reaction will come, vertical reaction. The vertical reaction will come, where is the formula? W1 plus W2 by 2 into L, 20 plus 50 divided by 2 into L is 2.5. 50 plus 20, 70. 70 by 2 is 35. 35 is 70. 70, half of 35 is 17.5. 87.5. See here, 87.5. And the reacting moment will be, what is formula? W1 plus 2W2 L square by 6. W1 is 20. 20 plus 2 into 50 into 2.5 square by 6. I will calculate it instead of wasting time struggling for divide by how much all. Answer will come 125, guaranteed. It has to come 20 plus 2 into 50 into 2.5 square divided by 6. 125 kilonewton meter. So make this observation. Now solve all these questions If I solve with the fixity at left side, you solve, I give a hint for you now. You solve with fixity at right end. And whenever I solve with fixity at right end, you solve that one first. Also solve fixity at left end. And now, next class, I am going to make a small announcement regarding reaction calculation. Then, marathon reactions will start. Okay. Rain started once again. Luckily, class over. Okay. Thank you. We'll meet in the next class.